Frankie is watching a video of the International Space Station with his grandfather. And in the video, astronauts are floating. They are floating in the air just like in water. Yes, Grandpa, they are 400 kilometers above the Earth. There's no gravity in space there. What? But how does gravity become zero? Newton's law should work there as well. It does, but it's very far away, so gravity becomes extremely weak. The moon is even farther than the space station, yet it revolves around us because of Earth's gravity. Frankie also fell into thought. Let's do one thing, Grandpa. Let's find out using Newton's formula. On Earth, acceleration due to gravity is 9.8 meters per second squared, which comes from this formula. Here, m is Earth's mass and r is its distance from the center, the radius. Now, if r increases, gravity will decrease. But for it to become zero, this distance would have to be infinite. Your math is correct, Grandpa. Since the space station is at a height of 400 kilometers, putting r plus 400 into the formula gives the value of g as 8.8 meters per second squared. This is still quite large, so how are astronauts floating? How can Newton be wrong? Newton is not wrong. Rather, this is a small gap in your understanding. Astronauts float because they are continuously falling downward, meaning they are in free fall. Since the space station and the objects around them are also falling with the same acceleration, they appear to be floating. If they are continuously falling, why don't they hit the Earth? Because they are also continuously moving forward at about 28,000 kilometers per hour. Let's understand this with an example. What happens if you throw a ball forward from a height like this? It will go some distance and then fall down. Now, what if you throw it even faster? It will go even farther. Exactly, but now throw it so fast that before it starts falling down, it travels so far that the Earth curves away beneath it. Now the ball will keep falling downward continuously, but it will never hit the Earth. It will keep moving around the Earth. I understand. This means astronauts are continuously falling downward along with everything around them. But the horizontal velocity is so high that before they can fall to Earth, they move ahead of its curvature. Yes, and the horizontal velocity required to stay in orbit is called orbital velocity. As we go farther from Earth, gravity keeps decreasing. What do you think? Will the orbital velocity increase or decrease there? The floating of astronauts can also be understood using the concept of centrifugal force, the same force that pushes you outward when you revolve in a circle. In reality, this is not a force but inertia, which resists change in direction. But in a non-inertial frame, it can be seen as a fictitious force acting on every object opposite to gravity. In this frame of reference, these two forces cancel each other out, making the net force zero.